This is a demo of encrypting local files and uploading them as assets, and then downloading those encrypted files and decrypting them locally. This is all done through a task called asset-crypt, and it's pretty cool because it uses the LLM to define functions for both the encryption and decryption process. So this won't be the smoothest of videos, but I'm going to stumble through it. So first we can launch Hi. I'm using a demo account. And first things first, I can confirm I don't have a public or private key pair set up. So let's do that first. That can be done through a Hi task called keypair setup. All right, so first it checks to see if I have a public and private key set up. The way this is structured is the private key is stored in my private assets, and it's a password protected private key so that no one who gets a hold of this on the cloud could decrypt it. And then my public key is stored in my public assets. So looks like I don't have it set up and is verified in this task. So now it's requesting to use the shell script tool to generate a new RSA key pair. So I'm gonna go ahead and allow it to do so. I'm gonna trust that this script it does works. Enter password to protect the private key. I'll go ahead and do that. All right, and now it's gonna do a series of commands in order to set up my account with this RSA key pair. Right. Okay. Without going into the exact minutiae of what's just happened, let me go ahead and just verify that yes, I do now have a private RSA key in my assets. And if I check my public assets, I can see I have a public key published in my public assets as well that any user can see simply by using /demo, which is the username of this account. Alrighty, well, we're now ready to use the encryption task, asset-crypt. Okay, so the first thing it wants to do is it wants to define a function that encrypts a local file using a randomly generated AES56 key. So notice that it's not actually going to apply this tool in any way. It just wants to define the function that will then be available as F0, as the /F0 command. So I'm going to go ahead and let it do this. The encryption strategy is every asset is actually given a unique AES256 key that's associated with the file, and then my public key is used to encrypt that key, and therefore only my private key will be able to decrypt the AES256 key to actually decrypt the file. So now it's asking to define a function for the decryption process. I'll allow it to do that as well. There it goes. Cool. Okay, and so something else to point out is that the /asset-temp command is used. And what this does is it actually takes this asset and makes a copy of it locally onto my machine. The same is done for my private key. And this is great because the LLM is aware that this copying has been done. And so it doesn't need to load my public key or private key into the actual chat conversation. It knows where they are in terms of files, and it can then use those in its functions and in its tooling without actually keeping that information in the chat context. That's important for ensuring that your keys stay local to your machine. They're not sent up to an LLM provider or an AI provider. Okay, so I have a file here called top secret. So I want to go ahead and say upload top secret as topsecret.encrypted.enc. So let's see if this works. You can see it's applying the /F0 command that it initially defined for encryption. And then it will do a set of other commands to do the actual upload. I won't get into too many of the details. Okay, so let's see if it's there. Yes, topsecret.enc is there. I can go ahead and verify that it probably looks encrypted. It does. It's a bunch of binary gibberish. Okay, the other thing I want to show you is that the information for how the encryption is done, or the key for encryption, is actually available through the metadata. So I can use metadata get on topsecret.enc, and you can kind of understand now how the algorithm was devised. Basically, the encrypted AES key is stored as a piece of metadata associated with the asset. So just as a reminder, every file, or every asset rather, can have metadata associated with it, metadata is simply an arbitrary JSON object blob with any arbitrary set of keys and values. In this case, we're using the encryption key for the encryption-decryption process. And it actually also just remembers which public key was used. And in this case, it's referencing the public key that's available through my public assets. Okay, great. So just for the demo, I'm going to go ahead and leave this task, leave high. I'm going to start it up again. And we're going to go ahead and run this task again. So the first thing I want to show you is that it loads more or less instantly. The functions initially defined were already cached. So it says they're actually retrieved from the cache. If for whatever reason you ever want to do a reset of these functions, you can use task forget so that these things are regenerated. What did take a momentary second was simply using asset-temp again to copy the public and private keys back into my local machine, because they are cleaned up after any session is ended. Okay, so yeah, let me go ahead and ask to decrypt topsecret.enc as topsecret. Let's just say decrypted. Okay, it needs the password for my private key. Let me type demo. All right, is it there? Yes. Let's go ahead and cat it. And now we can see that top secret, the top secret fed had my kake udon recipe. Alrighty. Something else cool that I want to point out. So topsecret.enc is unfortunately not searchable because it's in binary. So it was the server-side system is unable to generate a text embedding of it for asset search. But something that we can do is we can actually set a metadata key for it called title, and we can say kake udon. Now when I do ls, you can see that this asset has the kake udon title, and this is a common thing done for assets that you can do for assets. Now when I do asset search, I can search for udon, and I'll see the top match is in fact topsecret.encrypted.enc with the title kake udon, and it'll probably work even with like noodles. Yeah, it still works. Okay, so titles are a great way where you can still keep the encrypted file encrypted and secret. In this case, my recipe is not revealed server-side whatsoever, but the title is still searchable via an embedding search, which is nice and convenient. Okay, yeah, so I think that more or less concludes this demo. So yeah, I just wanted to show you a cool way where LLMs can assist you in the encryption-decryption process. I know some of you are probably thinking it's probably pretty silly and unsafe to have an LLM do this for you. And that is true today, but looking down, a year or 2 years from now, or even further into the future, you can imagine that an LLM could potentially be, assuming that you trust the LLM, and maybe it's running locally, the LLM could be something that you actually trust more than foreign sources, than using maybe a random GitHub package. It might be just safer to use an LLM to generate your encryption and decryption processes. All right, that's all. Thank you.